In this Precalculus Algebra video, we're going to talk about solving equations and inequalities graphically. Sometimes it turns out that you end up with an equation or an inequality that is really hard to solve algebraically. That is just by isolating x, factoring, and finding the values of x. So sometimes you have to rely upon graphing techniques. And here to the left, I have a free online graphing calculator. It's called Desmos. So you can just do a search for Desmos. It's super easy to use, really nice interface, and gives really results that are easy to work with. So I highly recommend it. So what we're going to do here, for this first example, we're going to solve this equation. So the instructions say solve the equation or inequality graphically. State your answers rounded to 2 decimal places. And so here's our equation. X cubed plus 3x squared equals negative x squared plus 3x plus 8. So this is a very hard equation to solve without a calculator of some type. So luckily we have some tools at our disposal. And what we like to first do with an equation like this is we like to set everything equal to 0. So I'm going to move all these terms to the other side, and I'm going to get x cubed plus, let's see, I'm going to add x squared to both sides, so 4x squared, and then minus 3x minus 8, and then I have is equal to 0. So then what we do is we set this whole left-hand side, that polynomial, equal to a function. So I'm going to say the function f of x is going to be defined to be just the left-hand side. So the function f of x equals x cubed plus 4x squared minus 3x minus 8. That's my function. And so what's this equation asking me to do? It's saying, hey, find where your function, which I just defined, is equal to 0. So I want to know when this is equal to 0. But whenever you find where a function is equal to 0, you're really looking for the x-intercepts. So what we're going to do is we're going to graph this function using Desmos, and then we're going to look to see where it crosses the x-axis. So let's do it. So I'll come over here and we'll enter our function. Now when you do that, we're going to replace f of x with y. So it's going to be y is equal to x cubed plus 4x squared minus 3x minus 8. So let's try minus 8. So there's the graph of this function. And now sometimes you have to kind of play with the axes, the scales, to get it right. And you do that by clicking on this and controlling the graph settings. So we don't need to here because I can clearly see where the intercepts are, right? I have an x-intercept right here, and you can see that Desmos puts a little point on the graph for you. So the first x-intercept is at negative 4.26, rounded to 2 decimal places. So my answers would be x equals negative 4.26. That's the first one. Where's the next one? X would be negative 1.24. So x is equal to negative 1.24. And the final one would be right here at 1.51. So the x-intercepts of my graph are where this is equal to 0. That's the same thing as the solutions to this being equal to 0 are the same as the solutions to this top equation. So these would be my 3 solutions that I found graphically using Desmos. Okay, now what about an inequality? Well, the same logic applies, and the way we're going to handle it is we're actually going to handle the next example. We're going to see where this polynomial is not equal to that one, but greater than or equal to that one. And we'll see what that looks like using Desmos again. So let's do that now. So we've changed from x cubed plus 3x squared being equal to the right-hand side to now it's greater than or equal to that. So once again, we still write x cubed plus 4x squared, getting everything on the left, minus 3x minus 8. But now it's greater than or equal to 0. And once again, we say, okay, the function is the left-hand side, x cubed plus 4x squared minus 3x minus 8. And what we're asking for now is not for intercepts, but we want to know when that function is what? Well, greater than or equal to 0. Greater than or equal to, let's rewrite that. So where the function is greater than or equal to 0. And what does that mean? Well, f of x is basically the y-coordinate, right? So we want to know when the y-coordinate is basically greater than or equal to 0. And when does that occur looking at the graph? When is the y-coordinate positive? Well, from negative 4.26 to negative 1.24. For all the x's in there, I can see that the y-coordinate is above the, well, the y-coordinate is positive because the graph is above the x-axis. But then when I go here, right, the y-coordinate is negative, so I don't want that interval between those intercepts. But then beyond 1.51, I can see the graph is positive again. That is, the y-coordinates are positive. So I want this interval in here because the y-coordinate is greater than or equal to 0, and I also want from 1.51 and beyond. So my solution to this graphically was negative 4.26 all the way to negative 1.24. For all those values of x, the y-coordinate is greater than or equal to 0. Union, right? I also want this interval here from positive 1.51 to infinity. So 1.51 to infinity. Okay, and this would be my solution set. These are the values of x for which this inequality is true based upon the graphical solution to this problem. Okay, until next time.